Welcome friends, let me show you the geometry of doing a variable substitution. So remember on this channel I post more advanced non-routine sometimes math videos. Imagine we have like an x plus 1 and the quantity is squared. And then beyond that we have, say, again, x plus 1 here. But then the coefficient here is make that as 7. And then at the end we have a 10 and this is equal to 0. So what stands out here perhaps you can see is that like this and these repeat. So look, I can set u equal, right, to that. So I'm going to have u squared plus 7u plus 10 is equal to 0. Now, this is the beautiful part, the geometric part of it. What is happening here when I do this, actually? So one way to visualize it, let's see, I'm going to make sure I can fit it all. It's like you draw a coordinate system this way and then this way. So this is x space and then this here is u space, you see? And notice that you're basically saying that u is equal to x plus 1. And then that means the following. When x is 0, what do you have? Well, that means that u is equal to 1, correct? So you're about here, say, when x is 0. So this is x equals 0, but u equals 1. On the other hand, just to get pin it down a little bit more, when x is 1, then this is u is equal to 1 plus 1, which is 2. So when x is 1, say, then u is about here. It's equal to 2, right? Like this. So in other words, it's going to give you a line that looks like this, you see? So this is u is equal to x plus 1. And this curve maps between x space and u space. But notice something, that in terms of solving the original equation, it's got that x plus 1 expression. This is just u, right? So this can be done more easily because you can just factor this. In other words, it's like saying, okay, two numbers that multiply to 10 add up to 7. So, it's going to be u plus 2 and then u plus 5 is equal to 0. Those work. So now u is negative 2 and then u is equal to negative 5. Let's see whether you can visualize the rest of this. It gets a bit more interesting story. This curve here, u equals x plus 1, it will just continue, basically going this way. So that means the negative u axis would be like about here somewhere. So u equals negative 2, so that's negative 2 here, and then u equals negative 5, so that's negative 5 right there. So what you would have to do now is, this is the solution in u space, correct, to the equation. In other words, u squared plus 7u plus 10 equals 0, and u space is just like a parabola. It pretty much looks like this, you see, along the u axis. And it opens up because this is a positive 1u squared. But now, you got to get back to x space. So what do you do to get back to x space? Well, you have to transform back, right? So since u is equal to x plus 1, and this tells us that u minus 1 is equal to x, correct? That's how you return. In other words, now you're just going to feed values of u back to that same curve, back to x space. That's what it's doing, see? So for example, let's see, where are we? So when this is negative 5, how could you make use of this curve? Well, you got to, again, imagine it's like a three-dimensional coordinate system, essentially. Or when u is negative 2, right? It's going to go here, it's going to bounce off the curve and head back the x-axis, right? This is going to go this way, bounce off the curve, and head back the x-axis somewhere over here, for example, you see? It's a beautiful geometric characteristic of all this entire process. You can visualize all of it. Anyway, so let's solve it. When u is negative 2, so negative 2 minus 1 means x equals negative 3, like this, negative 3. So say that's somewhere about here, okay? It doesn't have to be perfect, but x equals negative 3 right here. And then when u is negative 5, you're going to have negative 5 minus 1 as x, basically. So that tells us that x is equal to negative 6. So let's say, that's somewhere over here all the way. This is x equals negative 6, and this is x equals negative 3. So the basic benefit always of a variable substitution is make something hard, like trying to solve this with this x plus 1 and this additional x plus 1, and then make it into something like this, which can be done pretty, quickly just by a simple factorization. But then the downside, or a step you have to remember, is that you have to then transform back to the original variable, the way I did here, by writing down, let's see, these right here to get back to x. And this is the geometric interpretation of it all. If it's been helpful or interesting, please be sure to like and subscribe. Thanks.